groups. Now, we know that there are literally thousands of different types of minerals that exist on the surface of the Earth. And all of these minerals have interesting and unique characteristics: color, crystal structure, even taste and smell. Now, while that variety is certainly interesting, it makes studying minerals a little bit of a challenge. And so the idea behind this video is to take a look at how minerals can be grouped on Earth. So let's dive right in. Minerals can be classified into one of 8 different groups, and that's typically based on their chemical composition. Now, that's a mouthful. Before we move on, let's break down some of these words, starting with the word classified. Now, if you're not familiar with the process of classification, this is essentially grouping something based on a shared characteristic. Let's look at an example using something simple like playing cards. I have a random stack of playing cards here, and I can group or classify them based on any number of different characteristics. For example, we can put all of our red cards together and all of our black cards together in a classification based on color. Or I could put all of my hearts together, clubs, spades, diamonds, and that would be a classification based on suit. I could even do something different, like put all of my face cards together and all of my number cards together, and that would be a different way of classifying these playing cards. Now, minerals, as we mentioned, can be classified into these 8 groups, but it's based on their chemical composition. And that's just a fancy way of saying what the minerals are actually made up of. And so let's dive in and take a look at those 8 groups. Here they are. What we're going to do is look at each of the 8 groups in a little bit of detail to understand the characteristics of the minerals found within each group. Starting with number 1, our silicates. So, silicates are the largest mineral group, and there are more than 1,000 varieties of minerals that are in this group, and those minerals make up nearly 90% of the Earth's crust, so very common on Earth. What makes them silicates is that they have a basic building block called a silica tetrahedra. Now, this is an atomic structure within the mineral that is composed of 4 oxygen atoms that are bonded together with 1 silicon atom. And it kind of looks like a pyramid structure, something like this. So you can see the green are our oxygen atoms with that central silicon in the middle. And that's what silicates are composed of. The most common silicate minerals on Earth include feldspars like potassium and plagioclase feldspar, and things like quartz, which we see all over the planet. And those are silicates. Next up, our native elements. These are particularly interesting. These are minerals that are composed of only one element. Because of that, they tend to be extremely rare and therefore quite valuable. Native element examples include things like gold and silver, diamond, and sulfur. And of course, these are some gold mineral samples right here in this image. So those are our native elements. Next up, our carbonates. So carbonates are interesting. They have a basic building block of 1 carbon atom that is bonded to 3 oxygen atoms in a structure that's known as the carbonate structure. These are made of 1 cation bonded to the carbonate structure. So what is a cation? Well, this is just a positively charged ion. You learn more about this in a chemistry class. Elements that are cations include things like iron, calcium, magnesium, and lead. And when you have those cations bonded to the carbonate structure discussed earlier, we end up with a carbonate mineral. The most common example on Earth would be calcite, seen in the image here. So those are our carbonates. Next up, our halides. So these minerals are salts, and these are salts that form when you have naturally occurring salt water that evaporates. The resulting mineral or rock is known as an evaporite. So these halides are generally ionic minerals. And what that means is that if you were to put these minerals within water, they will tend to dissolve. And that makes sense. The chemical elements that are called halogens examples of which include fluorine, chlorine, and iodine. These halogens will bond with metallic atoms, and the result will be a halide mineral. So these salts form when things like fluorine, chlorine, and iodine will bond during the process of evaporation with some metallic atom, and you'll be left with a halide mineral. The most common example of this is halite, which is also salt as we know it. Of course, there are other examples of halides as well. Next up would be our oxides. So oxides have one or two metallic elements that are bonded specifically with oxygen. Hematite, magnetite, these are common examples of oxides. Both of them contain iron bonded with oxygen, just in varying amounts. You can see some really interesting samples like this hematite shown here. That's a great example of an oxide mineral. Next up would be our phosphates. So these are very uncommon minerals, and they're going to contain a structure that's pretty similar to that silica tetrahedra that we discussed earlier, found in silicate minerals. The only difference here is that instead of having a silicon atom right in the middle, for phosphates, we will have a phosphorus atom right there in the mineral. What's unique about these is that most commonly they're found actually within human bone. The phosphate mineral apatite is found within human bone. You can see samples of it right here. It tends to have this very pretty blue color. And so those are our phosphates. Again, much less common on Earth.